In this video I want to show you how you can use Facet Wrap or Facet Grid to turn one busy and not too informative chart into a chart that allows you to make much clearer comparisons. This is actually really easy in R. Imagine you have a plot that shows the temperature of different states on an annual level. All you need to turn this into a seasonal chart that shows you the differences from summer to winter. In R, that's just one line of code that you have to add at the end of your code block. And this makes it really easy to create comparisons based on different time frames. It allows you to make comparisons between categories of your data set in a much more clearer way for scatter plots, but also I will show you how to do this for box plots and go through different variables of your data set to find differences quickly. I will even show you a quick trick to order car models based on different variables within one chart. And then of course I will show you the differences between Facet Wrap and Facet Grid. We will go through the function arguments so you really understand how to use them. And in the end, I will even show you a bonus trick on how to combine different types of plots like scatter plots and box plots. There will be a table of content in the description below. If you want to skip ahead to certain areas that interest you more, feel free to do that. So let's get started with the first example and our code. Let's start with an example using the gapminder data. This data frame contains over 140 countries with their life expectancy, population and GDP per capita for various years. If we plot the data for the most recent year, excluding Australia and New Zealand, we can see that with increasing GDP per capita, the life expectancy also increases. To avoid this empty space, we can use a log transformation, which is often recommended when you work with price data. You either include the log10 function within a statics mapping of the ggplot function, or you keep it as it is and follow up the plot with the scale x log10 function. And I recommend doing the latter because here you can also include the label dollar function from the scales package that allows you to transform these values into the dollar price points, which are easier to understand. And with annotation log ticks, you can show where 2000 would be, 4000, 5000, etc. Because the spacing in a log transformed axis is not linear. Now it's very easy to use the continent information as well for coloring these points based on their respective continent, where you can see that many African countries cluster in the poorer region with lower life expectancy, and the European countries cluster more in the top right area of the plot. You could also map the country name to label within the ggplot function and then follow up with the geom_text function with size equals 3. But now it becomes really difficult to differentiate the countries, especially in these areas where they overlap. And here the Facet Wrap function can help. All you have to do is use the Facet Wrap function within the plot commands and use tilde versus the continent variable. There's an extra column that maps one continent to each country, and when you use this, you get 4 plots, one for each continent, only holding the countries that belong to this continent. And now that we have the continent information on top of each plot, the legend is no longer needed, and you can remove it in two ways. Either you use theme legend.position equals none, or you add within a geom_point function show legend equals false, and then also the legend doesn't appear. The first function argument I want to mention for the Facet Wrap function is the scales argument. By default it's set to fixed, which means that the values you see for the y-axis and the x-axis is identical for all 4 facets. When you set it to free y, then the y-axis is now different for each plot, so the GDP per capita is fixed, but now you see that for Europe the life expectancy ranges from 72 to 82, and for Africa it ranges from 40 to around 78. You can also free the x-axis and keep the y-axis constant. Now the prices vary and you see the GDP for Europe is a lot bigger than for Africa, and when you use scales equals 3, it will vary x and y values for each individual continent, making use of the space more efficiently, but now it's more difficult to compare the continents amongst each other. I will talk about other function arguments in a minute, but just to finalize this example, here's the plot where you can use ggrepel instead of geom_text. text to add the country names to the individual plots. And now you can see for each continent which countries perform the best and which are lagging behind when it comes to life expectancy or GDP. And it's also very easy to make this plot interactive with the ggplotly function from the plotly package. I'll just use the last value, which is the latest plot that I did, and hand it over to the ggplotly function. And now you can see that when you hover over a dot, you get the information of GDP and life expectancy and the country name. And it also works for the zoomed out plot. Moving on to the function arguments of FacetWrap, you can use question mark or help to get the description of this function with the arguments. You can also type FacetWrap and then open parentheses and hit the tab key on your keyboard to see which function arguments are available with a short description of what they do. And we already covered the scales argument where it's fixed by default and then gives you the other options that are available. First I will cover the nrow and ncol argument. When you set ncol equals 1, then all the facets will be arranged in one column. When you set nrow to 1, then they will all appear in 4 columns and only 1 row. The strip position argument tells you where the label of the facet should appear. By default it's top, but you can set it to left to have the text being displayed on the left, and you can also choose bottom and right. There is a general theme argument that talks about the strip placement, and you can set it to outside and then move it outside of the axis in case you ever want to do that. Now I want to talk about 2 ways how you could change the labels of the facets, because sometimes you use the FacetWrap function against a variable where the names might be coded or some factor that's abbreviated, and there are 2 ways to change that. The first is using the labeler function argument within FacetWrap. So there's a labeler argument that can be used, but it's not trivial on how to do that. What you need is a vector with the new labels that you want to assign. So here I choose continent, column, and then Africa, Asia, North and South America. That's how I want to change it. And that gives you just a character vector with 4 elements. And now we have to name the elements of these vector, which we can do by using the names function. So now we assign the original names of our data frame to this vector. And now the structure function tells you that this is now a named character vector with these names. You could also have accomplished that in one go by creating a character vector with the equal sign, where you start with the named function argument will be this. So now new labels 2 is the same as new labels, just a character vector with named entries. And now all we have to do is pass this new labels object to the asLabeler function of the labeler function argument of the FacetWrap function. And when you do that, the old names get replaced by the new ones. And now I noticed that I forgot to add the continent information. But that's the good thing about programming. It's easy to fix errors and repeat the code. If you don't want to use the labeler function, of course you can always create a new column in your gapminder dataset with the mutate function, where you would say that the new label is based on old labels and use the case match function, or you copy the whole column and then use gsub to replace the original value with a new value. But case match is pretty easy to do. Every time it detects Africa, you assign this new label and you continue this for the other continents. So now when I look at the gapminder dataset, there will be a new column at the end that's called new label. And now when you use the FacetWrap function, you wouldn't plot it against continent, but against the new label column, and you would get the same result. It is possible to use the FacetWrap function for 2 columns, so 2 variables of your dataset. Imagine not only using 1 year, but 3 years. And keep in mind for every year we have all of the countries available. So just picking the first one in the middle and the last one. You could use the facets argument and a formula where you say you want to see the continent for each year that's available. So now you have the Africa data for 1952, 1977 and 2007. And then it repeats for the other continents, telling you that there's a trend of countries from one continent moving to the top and to the right with increased wealth and life expectancy. And we will talk about the facet grid function in a minute, and you will already see the differences of how rows and columns are labeled. But if you want to flip the continents and the years, you would just change the order of the formula. And now it would be advised to set the number of columns to 3 to now have the continents as rows with increasing years from left to right. The first thing I want to point out with regards to the facet grid function is that when you use this formula to plot year versus continent, so choose one fixed year like 1952 for the row and have all the continents as columns, this formula worked for facet rep and it also will work for the facet grid function. However, for facet grid, the row indication becomes more clear. So now you have your own little box indicating the row value. However, the facet grid function comes with a dedicated row argument and a dedicated columns argument. And here you have to be aware that just handing over the column names of your data frame will not work. It will give you an error message. To make them usable, you have to include them within vars function. So now it knows that the gapminder data frame has variables named continent and year, and you can use them within the facet grid function. So now it works perfectly. If you change the arguments, flipping the columns and the rows, it will automatically change the number of columns. So within facet grid, there's no ncol or nrow argument anymore. It will automatically detect that there are 4 continents that you first had for columns and 3 for years. And when you switch them, it will move to 3 columns now, but 4 rows. You can look at the function arguments again with the help function. The scales argument is there again, but for space, I want to link to a web article that was published on our bloggers, and it shows you that when you use space and set it to 3 for either the X or the Y axis, it will use different sizes for chart space. So it will make the individual facets only as big as the data that is included for plotting. You can again use labeler. Next I want to show you what stable does. When you plot year versus continent, then the rows will by default be as a table with increasing values going down. But when you set this to false, it will just flip the row order, now going from biggest to smallest. And the same happens when you switch continent and year. By default, it's alphabetically going up, but if you set it to false, it will flip the order, now going from A to E, from bottom to top. When you use the switch argument, for example by setting it to X, it will flip the labels on the X-axis, so now they go from top to bottom. When you set it to Y, they will move from the right to the left, and you can also flip or switch both, and then they are on the left and the bottom. When you include the margins argument and set it to true, it will now include all of the data that's available for a certain variable. So now you not only get the split by continent from 1952, but you also get all of the data combined in a dedicated column and row, which means at the intersection of the all row and all column, you get all the data points for all the years in continents of the gapminder data frame. One important difference that I want to point out between facet rep and facet grid, that's not only regarding the aesthetics of how the facets will look, is when you plot, for example, from the MPG data frame, the city mileage versus the displacement, so bigger engines will usually use up more gas and then the mileage decreases. If you use facet rep, based on the combination of cylinders and the drive, which is either four-wheel drive, forward or rear engine drive, you will see only the combinations that have actual data. When you use facet grid, it will include empty facets. So there is no car in the dataset that has 4 cylinders but a rear engine drive variable. Same for 5 cylinders. These only appear for the front wheel drive. So that's an interesting differentiation. The grid actually creates 1 row for the 3 levels of the drive variable and 4 columns for the 4 levels of the cylinder variable. And then it will produce a chart for each combination, regardless of there's actual data available. And for facet rep, it will build combinations only for those observations in your data that have information on city mileage and displacement. One more thing that I just want to point to and link to the article again in the description. For facet grid, you can actually combine 3 different variables. So plot color against cut, including the information of clarity for the diamonds dataset, where now you have 2 rows for different colors, but as columns, 2 combinations of variables. Now I want to show you a very cool trick that you can do by using the pivot longer function and facet rep. This allows you to plot data, for example as box plots, for 3 levels of a variable like cylinders, and then it gives you the values of different other variables like the horsepower separated by cylinders, the mileage, the quarter mileage time in seconds, and the weight. It also allows you to create a chart like this, where you get for 4 different variables like displacement or horsepower, the top 10 cars ordered by decreasing values for these different variables, again using the facet rep function. So we will use the empty cast data set that has 32 different models with 11 variables, and the first thing we have to do is add the model name to the data frame, because currently it's only stored in the row names. There's no dedicated column or variable for that. And we can just create a new one called model by extracting the row names of empty cars. And now we have a model variable. And as I said, we need the pivot longer function, and we use it the following way. First, we only select variables of interest, and then you follow up with the pivot longer function, and you state that there are certain columns that should not be transferred from the wide to the long structure. So we exclude them with the -c. And then we say that the names should be stored in a column called variable. So now it keeps the model and the cylinder variable, as indicated here, but for all of the other columns like MPG, HP, weight, and QSEC, it will store the associated value in the value column and the original category column in the variable column. So when you look at this selection of columns, you see that for the Mazda RX-4, you have 110 horsepower and a weight of 2.62, which means that when you use pivot longer, it will start with the Mazda RX-4 and a mileage of 21 and a weight of 2.62. So it stores all of the information, but now in a long format, which we will use for ggplot. And what we can do now is, after the pivot longer, we have the cylinder column that we can put on the x-axis as a factor, 4, 6, and 8 cylinders. We have the Y value that will be placed on the Y-axis, and we can use the variable information for facet rep. So instead of showing all of the values in a mixed plot, including displacement and mileage and seconds, we can add facet rep around the variable column. And now it should create one facet per variable, creating a plot like this, and we already know how to fix the different scale by including scales equals 3. Let me show you another very useful example for facet rep. Imagine you want to show bar charts of the models for different variables and then color them based on the transmission being either automatic or manual. You would do a pivot longer again, now including the AM variable and not the cylinders anymore. But now you don't want to show all of the cars, but only the top 10 models within each variable. To accomplish this, you would follow up the pivot longer function with a group by that states that within each variable group, you want to order or arrange based on descending values, and then only select the top n, where n is equal to 10. For this you can choose the top 10 models, and you see that it orders the first 10 highest values for displacement. Don't be surprised that there's a horsepower value that's within here. It will continue to group and order the first 10 and only show these 10 displacement values. So it won't show any other engine size after the first 10. Same for horsepower. Once the first 10 biggest values are there, it won't continue with any more observations, and it does the same for the mileage and the weight. And now we want to keep the order, which we can accomplish by creating factors. And there's a special function that can do this factor reordering within a group variable that comes from the tidy text package, and it needs an x, by, and within function argument. So we would follow up with a mutate to create or overwrite the original model column. Maybe we store it as model 2, and we use reorder within this vector of x by the specific value. So by these values in decreasing order within each variable, which was the original name we choose. Maybe we should call it category, and then it would be within category. So let's do that, because I keep talking about variables when I mean within the certain category, being displacement or horsepower. And what's created now is a model column that holds factor with certain levels that change depending on the category. So it knows within displacement how to order these models, and within horsepower, etc. What you then do, you pipe this result into the ggplot function that now puts model 2 on the x-axis and the value on the y-axis with the transmission fill as a factor. You add geom_call for the bar charts, use coordinate flip to flip x and y values, and then choose facet rep against the category. So now within each category we have our ordered models with decreasing values. X and y is flipped because then it's easier to read the model name. And to get rid of these underscores and the category label, you would follow up with a scale x reorder function. It's very important. It changes the model names. You can add a scale y continuous expand, the difference being that it now expands to the limits of this axis. making use of all the space that's available. And with the labs function argument, you can remove the original X and Y labels, which used to be model2 and value. You can add a title, and you can choose the fill argument that we originally used to indicate the transmission difference to label your legend. So transmission, line break, 0 equals automatic, another line break, 1 equals manual, makes the color coding within each category easier to understand. So the cars with the highest horsepower have manual gear shifts, being the Maserati and the Ford. Usually the cars with the best mileage also have manual gear shift, but then the cars that are really heavy with big engines, they were produced in the past. This dataset is from 1974 with automatic transmission. And if you want to change the labels within the facet title, remember that there was a labeler function, so you can create named vector arguments again and store them in the long labels vector and use that within the facet wrap function for the labeler function argument. And this is how you can easily replace the short values with longer ones. One last example, you might be familiar with the iris dataset that shows the petal and sepal lengths of different iris flowers species, and it can be useful to use this pivot longer trick to visualize the differences of your variables. So the data comes with 4 columns and a species column that shows the lengths and widths of sepal and petal leaves, and when you use the pivot longer trick, you can again change that into a long data frame with category and value for the different species. So calls exclude species and names to its category, and then it will move each value to the category name. You can plot that with a geom box plot and geom jitter to show the points, but now it's for all the different categories combined. So what you rather want to do is use facet wrap on category to create one facet for each category that shows the differentiation between the species. And with scales 3y, you can show more of the differences within each category. And it becomes clear that for the petal attributes like length and width, the Setosa species is very different than the other two. But for sepal, length and width, there's more of an overlap, and it looks like it will be harder to differentiate between the 3 species. But when you actually plot them for sepal width versus sepal length, the combination of the two allows you to actually fit a very good line in between them. So a support vector machine model would be able to clearly differentiate between Setosa and the other species, even on these 2 category variables. At the end, I want to show you a way to combine different kinds of plots. So far, we only had scatter plots or box plots or column charts or bar charts, but there's an easy way to combine different plot types with the ggarrange function from the ggplot package. And for this example, I want to use the diamonds dataset, which has over 50,000 rows, and I only need 5,000 to get the point across. So what I would do is sample 5,000 numbers from 1 to 53,940, which is the n row of diamonds, and I don't want duplicates, so replace equals false, and then you get random numbers. And this we can use to subset the diamonds dataset into smaller ones that are called diamond 5k. And now there are different ways to do this. First, I plot the price versus the weight in carat, and I use the cut, which is either fair to ideal for coloring the dots. You add geom point and then use facet grid against cut, and you can repeat the same with geom box plot. Use alpha to make it a little bit more transparent, and then you don't plot these charts individually, but you store them in 2 different object names, P1 and P2, and with ggarrange you can simply combine them and specify the number of rows, and then you get this summary plot. I hope you found this video helpful and learned a lot about multi-panel plots in R and how to generate them with facet wrap and facet grid. In the future I want to make a video about patchwork and cowplot along with ggarrange and grid extra that are more sophisticated in combining different chart types. So subscribe to the channel and hit the notification bell to see when a new video comes out. See you then here at the Data Digest.